Hello, everybody. Meteorologist Jim Rinaldi taking a look at updated look at the severe weather potential for the plains and Midwest as we head through the midweek period. We'll start here with the NAM for 18Z on Wednesday. And what you want to look for to start, this is always a good base to start with, is where your high dew point air, usually around 60 plus, sometimes you go as low as like 56, 57 dew point air, but I like to start about 60, is intersecting 1,000, at least 1,012 millibars. 1,008 being more ideal, but 1,012 will get the job done if you have a rapidly developing system. Okay, so here's this is our 1,012 line here. 1,012 millibars there. Here's our 1,008 millibar in here. And 1,004. So those are our pressures. And then here's our 60 dew point air starts right in here. This is our 60 dew point air here. So you can see here we have, you know, quite a large area of 60 plus dew point air intersecting, you know, sufficiently moist, sufficiently low pressures, I should say. So that's that. And here is our low pressure system taking shape in the lee of the Rockies. Here's a very well-defined warm front through here, and we have our cold front / dry line down here like that. So we have the moisture and we have the surface lift to go with it. So now let's take a look here at our low-level jets, and you can see now here we're starting to see a nice jet starting to form here, 925 millibars. You can see all this in here is 25 knots of wind speed. Here we get up to 35 in this blue area in here. So, you know, nice very low level jet there. We go up to 850. And you can see we're still seeing a nice jet there. And unlike yesterday on Wednesday, we're starting to see a little bit more turning of the wind in here. Look here. Oh, we'll go back here. Here's you can see here it's pretty much due south. You know, across this whole region here, that's all pretty much due south. But we get up here to 850, and now we're starting to turn south-southwest in there. So we've gone from this to that. Okay, so that's something to be watching for. We'll go ahead here to 700 millibars. Very nice jet at 700 millibars forming out here. Still seeing about a south to southwest wind in there. Go to 500 millibars, and you can see here's our trough coming in. Still kind of open, but it started to, yesterday was a positively tilted. Today it's a more neutral tilt in here. And look at the direction of the wind now. Now we're west-southwest at 500. Okay, so we've gone from, in this region here, from due south at 925 millibars to west-southwest there. And we're also having a nice speed shear that's happening in there as well. So that's, you know, that's very important. You know, we're talking about possible tornadoes in an environment like that. We'll go up here to 300 millibars. There we go. There's 300. And the divergence today and Wednesday is better than it was yesterday as well. You can see here in this region, here we have winds like this, and then they come up like this. And as we talked about yesterday, that opens the gate in here for thunderstorm development and for tops to, you know, keep growing into the atmosphere for a stronger storm. So those are our height levels. Here's our cape for the day, and you can see very unstable air through this region here. Now out here it's unstable. There might be a few thunderstorms out here, but the dynamics are not out in that area just yet at this point in time. I think the dynamics are going to be concentrated. You know, I think the area you want to focus on is you know, back in here like this. That's kind of the target area. I'm thinking at this point in time anyway. So there's our cape. This here is our energy helicity index. Now this is somewhat important here. What this shows is how much spin basically there is going up through the atmosphere. Now this goes up to 3,000 meters, 3 kilometers, and you know, the area that we were focusing on, that's showing the best spin. And remember, we showed you those the twisting of the wind with height going from this southerly direction here to the west-southwest at 500 millibars, and that's showing up nicely in the AHI. Here's our lifted index. A lot of lift going on in this region here. Here we have, this is around, what is that, about -11 lifted index in that same region. So that's, that's going to be very important. Here is our bulk shear. And again, we're seeing at least 40 knot, 35 to 40 knot shear, 50 knots plus in this, that same region. So, a lot of ingredients are starting to come together in, in this region here, south central Kansas, north central Arkansas. So, I'm sorry, Oklahoma. That's kind of where things are coming into focus there. Now, here's something I want to show you here. This is our helicity. Now, normally when you have about a 40 knot plus shear, you want to see a helicity of around 150 plus. Now, here is the 150 line. That's where the yellow line starts there. So it's not quite into, it's a little bit into northern Oklahoma, but it's mostly, in that area we're focusing on, it's more into south central Kansas. But here's an important factor. When you have, when you're looking at your 3 kilometer helicity, what you want to see if you're looking for tornado development is to have a lot of that concentrated in the lower part of that 3 kilometers. So now let's take a look at the 1 kilometer, and you can see, indeed, down through this region here, you do have a lot of this helicity concentrated in your lower levels. So, even though maybe, when you're looking at the 3 kilometer, it's not quite reaching criteria into Oklahoma, it's maybe just barely. When you look then in the lower levels and see that it is concentrated in those lower levels, now you want to start thinking, about that whole region again that I've been circling in the last couple of maps. This southern Kansas, northern Oklahoma region as your target areas for possible tornado development. Now, I'm not saying there can't be tornadoes outside of this region, but I'm just thinking that that's going to be the, maybe that's the focal point. As we're going into that. I'll go ahead now. Now we're going to have to use the GFS for Thursday because the NAM doesn't go out this far. This is 18Z on Thursday. And you can see our low pressure system has really, really wound up here. It's still 1,000 millibars. Well, actually, it's 996 at this point. But you can see now, here's our high dew point air. This is our 60 line in here. 60 dew point air, 65, 70 down in here. But here's something that's really important to note, in that our 1008 line is now a closed isobar. And when you have a closed isobar, oops, I came across the wrong line there, but let me see there. There we go. There's a 1008 closed isobar. 1004, of course, is closed. Everything under 1008 is going to be closed at that point. Closed isobars tend to indicate a stronger storm with more lift, and that's coming into our high dew point air. Here's our dry line, very well defined, coming into this region here. You can clearly see the dry line and our warm front up through there. So we have a lot of ingredients, just at the surface that are starting to focus, and this is the area here that I'm kind of focused on for this. Then this region, a little bit of, maybe a little bit more east, but somewhere, right in here, I think is what we want to be looking for. As far as, the focus, the main focus of severe weather. Not saying there's not going to be any outside of that area, just that's where, things are really going to heat up. Here's our low-level jet. There's 925. Very strong low-level jet at 925. I mean, 40 knots at 925 millibars is quite impressive. And we go up to 850, and you can see there's, we're getting up now at 45 plus in that same region, and we're starting to see that a little bit of twisting with height. Not quite as much yet, but then we get up to 700 millibars, and you can see the winds are now starting to go more southwest. 500 millibars. Now here we can see here our 500 millibar trough has now taken on that negative tilt in here. So that, you know, that's important too. Very strong jet. So we're getting speed shear, we're getting directional shear, and we're getting a good divergence here at 300 millibars. As you can very clearly see here, you can see our winds like this up here. Here's our winds down here. And we're getting that nice divergence right on top of the area I outlined before in eastern Kansas and western to central Missouri. We'll look here. Here's our cape. Now, this does not look all that impressive, but keep in mind, this is the GFS. It is not a convective model. This is a synoptic model, and it's out 102 hours. So I would very much expect these values to increase, you know. Well, I mean, the values themselves are going to be what they are, but for the model to pick up on the fact that it is going to be a higher instability area out in here. So that's kind of my expectation. That's usually what happens. Here's our bulk shear. We can see here that, you know, we're certainly sufficient, 35 to 40 plus all through this region here. Now this, the GFS, I cannot get the helicity or the AHI for you, so that's why I'll have to end that there. I just wanted to show you this here. This is the NAM sounding from the Wednesday thread. And you can see here, very strong capping inversion, you know, across in this region. This is across northern Oklahoma, southern Kansas area. You know, so very strong capping inversion here. But our convective temperature should easily be reached. Okay, you can see here, you know, if you take the surface dew point up along the mixing ratio till it hits the temperature line, take it back down the dry adiabat, and we're pretty much almost at the convective temperature by that point in time. You know, so I think, you know, convective temperature might be about 27, 28 Celsius, about, yeah, around 80-ish, 81 should easily be reached in that area. And then once you get past that cap, you can see here, you know, it comes up along the saturation mixing ratio line. And yeah, I mean, this is all cape in here. You know, that would be all, you know, upward motion, all positive lift. So basically we hit about 82 degrees and it's just going to go boom, you know. So, and you can see here our, you know, our wind shear nicely. You know, here's our, you know, almost south to southeast, and then we're getting up here and we're west southwest, and then almost west up in here. And you can also see the speeds increasing with height as well. So, you know, it's not going to take much to get a tornadic sounding out of this here. Now we'll go to the GFS sounding at 102 for the eastern Kansas, western central Missouri region. And again, basically showing the same thing. Not as much wind shear being shown here. But again, this is the GFS. It is not a convective model. It's not going to pick up on a lot of these things as easily. And we have here's our inversion up in here. And but that should easily be broken. Looks like we're looking at a convective temperature. Let's see here. Take this along the saturation mixing ratio. Back down to the surface. Probably looking at around somewhere between 76 and 78 degrees, I think, to get that to go. And then once you do reach that convective temperature, well, there's your, very easy to see where your cape is in here. You know, that's going to be all cape in here. So, you know, again, that should be able to go. So, I think we are in the game here as far as the plains and Midwest for Wednesday and the Thursday for significant severe weather outbreak, including numerous tornadoes. Yeah, I think we're starting to be able to see the areas that are going to be maybe the most concentrated to get that. I'm not saying there can't be spots outside of that get it again. You know, this is not, you know, set in stone type of thing, but you know, I think that starting to be able to focus your attention on certain areas that are going to be more prone, I guess is the best way to put it. All right, I am meteorologist Jim Rinaldi. Hope you're all having a great holiday, and we will keep on top of this for you. Have a great day.